This is a rough sketch of a bridge rectifier I had shown a few days back. Now I'll try to build one using a breadboard and the components shown in the figure. Just to refresh the memories, this is the breadboard which I had shown yesterday. This is the rear side or the reverse side of the breadboard showing the metallic connections. These are the bus strips where you connect the positive and negative power supply or the ground. These are the connections between these terminal holes where you mount the components. I need 4 rectifier diodes for building a bridge rectifier power supply. I have them here. You can see 4 of them. If you look at this zoomed image, you can see that there is a ring here. There is a ring here on the one end of the rectifier diode. Here also there is a ring in this region also, but it is not so clear in this zoomed image. The ring will correspond to this portion, that is the cathode, and the other part will correspond to the anode. That is how you connect the rectifier diode in the circuit. Now I have roughly made the bridge configuration. This diode will correspond to this one. This diode will correspond to this one, and this diode will correspond to this one, and the fourth one will correspond to this. You can see that these 2 points are on the same line, so that it will be connected with the metal strip on the reverse. Similarly, these 2 will also be connected with the metal strip, and these 2 will be connected, as well as these 2. So there are 4 connection points in the bridge which we will have to connect to other elements in the circuit. As per the circuit, this point and this point will be the input from the transformer corresponding to these 2. Transformer input should go here and here. Now I need a high value filter capacitor to smoothen out the ripples in the rectified DC. So here I have a 1000 microfarad capacitor. The working voltage is 50 volt, which is well above the 12 volt power supply which I am planning to make. And this being an electrolytic capacitor, you have to think about the polarity. This is the negative part with a smaller pin and longer pin for a positive one. Now I have placed the capacitor in such a way that the positive pole is here. This will correspond to this region because it's in the same line, in the same row. You can see that it will be here. It is the same as this connection over there in the circuit. Then you have the negative pole connected here, which is same as here, and will correspond to this region. So I have completed the bridge. Now what remains is I have to connect the transformer from these 2 points. Here one lead of transformer should come and another lead should come here in this place, that is corresponding to this and this points. That has to be connected. Then you need wires to connect to the load. I am not showing the load here. Now I have connected 2 jumper wires, one corresponding to the negative terminal here. This is the negative terminal, and another corresponding to the positive terminal. I have given color coding also, black for negative, which comes from the negative of the capacitor, and the positive one which will be corresponding to the positive pole of the capacitor as well. So this is the output of the power supply which I connect to a load, whatever circuit you are going to drive with this. The final part, I will have to connect the transformer. This is a transformer which I can use for the power supply. This is a secondary output. You can see 2 wires going. That will be 12 volts. and this is the primary connection to the mains supply. The turns ratio will decide the voltage in the output. Suppose this is 230 volt and this is 12 volt output. That's a step down transformer, and you need a turns ratio of 230 to 12 to get a step down transformer. The number of turns will be much higher than 230 because you have to cover the current needed, and sufficient impedance to the alternating current should be there. So the number of turns will be much higher, and on the higher voltage side, as the current is lower and the voltage is higher, you will use thinner insulated copper wire, and on the secondary side, as the current will be more and voltage will be lower, you use a thicker insulated copper wire. That is the usual pattern in step down transformers. I have just removed part of the cover of the transformer just to show the laminated core. You can see that this core is made of several laminated sheets, and the lamination is needed to prevent eddy currents. The core will have eddy currents, will heat up the core, and that can be prevented by using a laminated core. And when eddy currents are there, that will cause generation of heat and loss of energy, so that the efficiency of the transformer in converting the power will be reduced if you use core without lamination. Core with lamination will improve the efficiency of the transformer. If you need better filtering of the output, you can use higher capacitance. Instead of 1000, you can use 2000 or even higher. And another way is to add an inductance along with that to smoothen out. A resistance can also sometimes be connected across the capacitor. That is an RC filter. That is also useful in smoothening out the output of the ripple DC to near DC. Good direct current will be obtained if you have such filtering circuits. If you use a step down transformer to reduce the voltage directly from the mains voltage to the required voltage, then it is a linear power supply. But as you have seen, the transformer is heavy. I cannot mount it on the breadboard. You have to mount it separately. Another method is to use switch mode power supply, SMPS, in which the current is converted into high frequency current, so that the 50 Hertz will be converted to high frequency using an oscillator circuit, so that the transformer works at the radio frequency level. You know that radio frequency transformers are much smaller for a given power rating. So the size of the transformer will decrease and the weight is also much lower. Only disadvantage is that for amateur radio operators, when you use an SMPS or switch mode power supply, there is a possibility of radio frequency interference from the power supply in your radio receiver, which needs other suppression circuits, RFI suppression circuits.